So first up, before we get into talking about torch height control, I went to start up my CNC router to cut this circuit board and heard the motor struggling for the Y-axis, and upon further investigation found out it was completely seized. As you can see here, there is no moving it. I use water as cutting coolant if I'm doing aluminum just because it makes it a lot easier to keep things cool and not have bits of aluminum melt into your bit and clog up the whole operation. And normally I block this water from being able to run down, but some must have gotten down in the motor last time I was doing an aluminum cut, and the machine sat for a little bit and just completely destroyed this motor. So anyway, I got a new one for 30 or 40 bucks off Amazon. Actually probably a little better quality than the one that was originally on it. And so I just wired it up, and you have to make sure I wanted to make sure that I checked the polarity as far as wire color and the runs in the motor, just to make sure that I got it right. But yeah, so just a little bit of this, and then we're on to cutting our circuit board. So after my last video about the torch height control, Andrew from ArcDroid reached out to me. He said it was good that I was putting this information out there, and he gave me a little bit more information through our email exchange. So I want to share some of that with you and give you some context as to what I have figured out, and he has managed to confirm for me, are the issues and what may be some possible solutions moving forward. So basically, Andrew had sent me a schematic earlier on for the torch height control input for the arc voltage. And no, if you ask me, I'm not going to send you the schematic. You can reach out to ArcDroid if they want to send it to you. They will. But in that schematic, I had noticed that there was a Zener diode. And basically, Andrew confirmed with me that this Zener diode is sort of responsible for the torch height control acting weird at higher voltages. So what has happened is they spec'd out a 5.1 volt Zener, and in their prototype machine or machines, that's what they had been using. But when it came time for production, they either switched manufacturer of that particular component, or it's a different batch, even though it is the same model number component. And it turns out that the roll-off that is in that Zener when it goes into voltage regulating is at a different point. It happens earlier. So for those that don't know, if a Zener diode is set up in a voltage regulator configuration, most Zeners will start to leak voltage around 0.7 volts. And they'll have a portion that, it's not necessarily linear, but it's close enough to linear, that they will leak more and more as the voltage goes up. When they get to a certain point, there's a little bit of a knee, and it's almost like a logarithmic curve that happens until they reach their regulating voltage. Well, because this particular Zener that is in all the machines that have been produced up until this point, or up until the point where they're going to change the SKU number for that production, we all have Zeners in our machine that start to be non-linear at a much lower voltage than what was in their prototype machine or machines. So this is why the 100 to 1 divided voltage works and 50 to 1 doesn't. Now, apparently, they sort of inadvertently have a switch that is in the machine that I'll throw a picture up here on the screen. If you flip that switch, it puts some other resistors into the circuit, or resistor, and basically gives you the equivalent to 100 to 1 divided voltage. This is what Andrew told me. I have not tried it. It should knock your voltage down to, or your TH value down to about 60, which is sort of getting close to the right range, but I still decided to make my own circuit board, my own voltage divider circuit, because of a few things that I'm going to talk about here in a minute. So the seemingly consistent results that I have gotten have all been on 18 gauge cold rolled steel. I'm using a lot of that for my art pieces and stuff, so that's sort of what I wanted to focus on first. I won't know if these results really are consistent until we get more time into it. You know, maybe I'll have an update for you in 6 months on how I feel about all this. I've also, I think for It's either 3/32 or 1/8" hot rolled steel. I think I have some settings figured out that will work, but again, going to need a lot more long-term testing to really know. But this sort of rolls into why I wanted to have a variable voltage divider circuit, and that is that for different materials, I want to be able to put the incoming arc voltage in the most optimal range that I can for the ArcDroid. And this is a key point for consistency with the torch height control, is getting it into a range, finding the exact divided voltage that you need, the exact settings, so that it doesn't do anything that's out of the ordinary. Once delay time's out, the cut just proceeds the way that it should, and it adjusts up or down with the material, and you minimize any ups or downs, even with acceleration or deceleration. So where does all this information leave us, and what does it mean? Well, I think that my advice from the last video still stands. That if you're considering buying an ArcDroid and torch height control is something that you're really going to need, make sure you reach out to ArcDroid, find out what the current status of it is, and you can even send me a message or an email or a comment. I can't guarantee you I'll get back to you as quickly, but I'll share whatever results I currently have. But ArcDroid should have a better understanding of what's going on, because they should be hearing back from a lot more customers, especially as more and more people get the beta test version or as this is rolled out. Now, I did put in a request with Andrew for one thing in the software to include is to be able to input a target TH value. And along with this, he also told me that they're going to be making some software changes. I don't know, maybe there's some algorithms in there that they're going to play with, because I believe the TH value, it's actually a number that's calculated from a number of factors, which includes the incoming voltage, the incoming arc voltage. So I don't know, maybe between all of these things, it'll sort of get it figured out, but having a target TH value, I think, will greatly improve the usability, because once you figure out that a specific nozzle at a certain amount of amps, at a certain cutting speed, registers a particular TH value, you don't have to play the guessing game of whether that delay timeout is going to happen during an acceleration or deceleration zone, and then you have sort of a screwed up value and it wants to do something wonky. So we'll see moving forward how this all comes together. I would like to say that through all of the problems that there have been, Andrew has been remarkably transparent and helpful, getting all of those things solved. I have no real affiliation with the company other than I bought their product, and now I've spent quite a bit of time, probably a month or more of evenings and weekends, really digging down into this problem and trying to figure out what's causing it and any possible solutions or patches that there might be. And my whole goal with that is to put that information out there into the community so that maybe we can build a base of knowledge and people can build off what I've figured out so far, and we can even see if this applies to anybody else. And as the company moves forward in their production, they put that 5.6 volt Zener diode in the circuit. Maybe that'll solve some of these issues, maybe it won't. We'll have to wait and see. Alright, so I got my voltage divider box all made up here. I've got a little hole drilled for access to my adjustment pot in there, so if I want to dial it up or down a little bit, I can. And this would also be useful depending on where you're taking your voltage from on your machine and what your setup is. You should pretty much be able to make this work with any setup. And I also made a breakout cable here. This end, of course, goes to the CNC port on the Everlast, and I got a similar connector but smaller that will go into this box, to the divided voltage box. That's going to be my in and my out are all on one connector. And I've got my spade connectors on this end, both from my trigger and for my voltage for my torch height control. Unfortunately, I ran out of spade connectors, and it's going to take me a little bit to get some more, so I had to reuse the old ones. So I had to solder them on there. Not optimal, but hey, good enough for what we're doing here. So I'm going to find a place on the frame. I think I'm going to mount this box with Velcro, just for easy access and so that I can adjust things if I need to. And that way I can also detach it very easily. So at least for temporary wise, this should work out well. So let's get into it. So for my setup, I'm running an Everlast 82i, and I am using the CNC port off the back for my arc voltage, but I am not using the supplied 50 to 1 voltage divider on the machine. I'm actually using pins 5 and 7, which I guess would sort of be their raw voltage pins. But if you look in the documentation, both pins 5 and 7 have 100K resistors that are in line, so you have to take that into account when you're setting up your divided voltage board. Now this isn't a big deal because we just hook up our multimeter and we measure whatever voltage is coming off of it, and we can adjust our divided voltage board up or down. So before you go and hook this all up, as I show here in the video, you want to make sure you do a dry fire of the torch to make sure that your voltage isn't going to be over the 3 volts. And I started out by adjusting my divider to 2.7K, and that gives me a dry fire voltage around 1 volt. During cutting, you'll probably notice it's around 0.85 to 1 volt, somewhere in there. And from there, I just do test cut after test cut. But you will notice, mainly on the thicker material is where I noticed it the most, but even on the thinner, after the delay times out, the torch will sort of either bump up a little bit or bump down a little bit before it continues its cut and follows the curve. This was one of the most difficult things to dial out, but this is why it's important to have that adjustable divided voltage circuit so that you can get this whole thing in the most optimal range possible for that circuit to read it and be able to adjust properly. And you will notice that eventually here on this thinner material that the torch actually goes into a wave-like oscillation. So this was the point at which I realized I had to go just slightly higher on my voltage. So I adjusted this up to 3.2K. That gave me a dry fire voltage around 1.15, 1.16 volts, and I did a pierce on a piece of material and it spikes up to about 1.6. So that's what I went with, and then I did some more test cuts. And you can see my TH value is in the mid-50s, and that one was sort of a failed cut. It wasn't adjusting properly. So I picked a different gain value that was just slightly higher for this material, and we see that it finally corrects. Delay comes in, and if you watch the carriage, there's almost no adjustment, and it just tracks perfectly along the material. So from there, it was time to actually test this on some 18 gauge material on an actual real world test cut, which is what I do here. Now in a second, after it cuts a couple of these letters, you'll notice that I end up stopping the cut because right here it goes into the wave like dipping and diving again. So I check to see on this next cut if it does a similar thing, and it does. So I stop it and I adjust my gain value just very slightly, and I believe I went to 1.3 on the gain here, where I'd started out at 1.5. So I just let the machine go through, and then I enable the torch for the next letter and watch it very carefully, and it's much better, but I still notice a little bit of weird oscillation. And you notice I did pick material here that is warped up, and you'll see at the end why. So I believe it's right after I cut out the O here. I decide that you can still see a little bit of dipping and diving. So I make one final adjustment to my settings, and I went to a gain of 1.25. And on this cut, when we get to doing the outline, you'll see how well this actually works. When the delay time's out, the torch just follows along the curvature of the material, and it compensates for how warped up it is perfectly. And even on the far edge, I had this cut a line because there's only so much space in the material. The torch nozzle was riding right on the very edge of the material, and by lowering the torch, it actually keeps the arc lit, so when it comes back in, it perfectly adjusts and goes along and completes the cut. So I think this really demonstrates why I wanted the torch height control working, and why I've worked so hard to get there, is because on these thinner materials, in order to preserve cut quality, as they heat up, they're going to warp. And having this automated process, rather than having to, take a stick or something and push down here and push down there, you're sort of getting something that can have a more accurate and repeatable result. So this was my setup with the Everlast. And again, my divided voltage board I had set to about 3.2K, and I was getting a dry fire voltage around 1.15. And these are the results that I came up with as far as reliable cuts. And I did a ton of test cuts to sort this out. So for 18 gauge material, and for most materials I've done so far, I find a delay of 1.7 seconds, and smoothing on 8 works very well. The only thing I vary at this point is the gain. And for 18 gauge material, 1.25 seemed to work really well. And the only thing that changes for the 1/8 inch material is the gain up to about 1.5. I'm sort of thinking that maybe 1.4 may end up working a little bit better for that. But those are the settings that I'm using so far. That's how I've gotten consistent results thus far. We'll see long term how this is going to track. And again, maybe 6 months from now, I'll be able to update with more complete results and be able to give you some actual hard and fast conclusions. So with all that out of the way, it was time to do a real-world cut. This was a commission project that I have, and probably the most complicated thing that I've cut. But I took a chance and enabled the torch height control and ran exactly the settings that we've discussed. This is 18 gauge cold rolled material, and there's a ton of pierces on this, a ton of outlines, and we'll see what the results are. So this was a very nerve-wracking cut. You know, with all the issues I have had with the torch height control, but you know, I did a ton of testing. I really prepped for this. I really made sure that I had everything dialed in, and I hit go, and as you can see, came out really, really nice. And I'm going to do another video featuring this piece, how it's all finished out and everything. So this is where I'm at with it. Hopefully this can help you out. And if you have any questions about any of this, you know, reach out to me. I'll reply to stuff as I can. And I guess that's about it for now. So we'll see y'all next time.